Let's look at doing the same thing with example 3. We have our original function is f of x, which is x cubed plus 12x squared plus 5. And we want to find the critical numbers, relative extrema, and determine where the function is increasing and decreasing. So first step to doing all of these things would be to find the critical numbers. Even if it just said determine where it's increasing or decreasing, we couldn't do that without finding our critical numbers first. So we take our derivative, bring down our power is 3, x squared, plus 12 times our power is 2 is going to be 24. And now we have x to the first, and the derivative of 5 is 0. So we're going to take our first derivative and set it equal to 0. And then we need to solve this. This is a binomial, something with two terms. So I'm going to pull out a greatest common factor. 3 is the biggest number that goes into everything, and x is my least power of x. So 3x times x is going to be 3x squared plus 3x times 8 will give me 24x. And set that equal to 0. So 3x can only be 0 if x is 0. So we could divide both sides by 3 and see that if you need to. Or you might just be able to tell 3 times something to be 0 would have to be 3 times 0. And then x plus 8 also needs to be 0. In order for it to multiply to be 0, one or the other has to be 0. If x plus 8 is 0, x must have been negative 8. So there's our two critical numbers, so I can already answer that part. We have two x values, so I have x equals 0 and x equals negative 8. So we can just put a comma between them, and remember, don't put parentheses around them or else it'll make it look like an ordered pair when these are both x values. So there's our critical numbers. These are the only numbers that could be a relative extrema, and they're the only numbers where we're going to switch from increasing and decreasing. So they're the only x values that can be in either of our following answers. And to figure out what our answers are, we're going to have to make our sign chart. And I'm going to label my two important numbers on here. My critical numbers. The first one is actually negative 8. And then my other one is 0. So I have my two special numbers here that make the derivative 0. And these are the two places, two x values, besides infinities that are going to be included in my intervals of increasing and decreasing. And they're the only two places I could have a relative max or min. Can't happen anywhere besides a critical number. So if we choose a number to the left of negative 8, again, I only care about the sign, so I'm going to plug in to my derivative and see what the sign would be. So maybe I'll choose a test value of negative 10. So plugging into this derivative here, we'd have 3 times negative 10, which is going to be a negative number. And then we'd have negative 10 plus 8, which would be negative as well. So if I choose any random test value, say we chose negative 10, we'd get a negative times a negative, which would be a positive. So any test value you want, you could throw it in there if you wanted to. Say the number that you tried. I tried negative 10, and it gave me a positive answer. Between negative 8 and 0, I'm going to choose negative 1. And I'm just going to see the sign when I plug into the derivative. So I have 3 times negative 1 would be negative 3. So that's a negative answer. And then I have negative 1 plus 8, which is going to be positive. So this whole interval, whether you chose negative 1 or any other number, you should get a negative times a positive, which of course is negative. So I went from increasing to decreasing. So you have a relative max at this critical number here. There's the x value of my relative max. Relative extrema can only happen at critical numbers. After 0, I could plug in anything I wanted to. Maybe you want to plug in 10. I'm just going to plug in 1. And I'm going to see the sign of it. So plugging into the derivative always on a sign chart. So plugging into my derivative here, 3 times 1 is 3, so that's positive. And then I have 1 plus 8, which is positive as well. So I get a positive times a positive. And I switch here. I was decreasing, and now I'm increasing. So this other critical number is also a relative extrema, because we have a sign change. And this is going to be a relative min. So my relative min and relative max are found. Maybe I'll start with what's easier to fill in. I am increasing Starting off at negative infinity, stopping off at -8. Remember, only critical numbers are in your answers for increasing and decreasing. Another place I have a positive derivative would be from 0 to infinity. We want to make sure we don't accidentally put one of our test values in here, and I didn't. My critical numbers were -8 and 0, and that's the only numbers besides infinity, so that should be in here. And I'm decreasing between my two critical numbers. -8 to 0 had a negative first derivative. And how to find these points? I know the x values are always critical numbers. So my relative max was at my critical number, -8. And to find the y value, this is the only time we actually plug into the function. Otherwise, in our sign chart, we're always plugging into the derivative. But here I plug this into the function. I did -8 cubed plus 12 times -8 squared plus 5. And the y value of my relative max happened to be 261. My relative min is at my other critical number. It doesn't always work out to be one of each. Sometimes you have both. Could be of one type, and sometimes maybe both are neither max or min. Maybe it's something always decreasing. But for this one, 0 was the x value of my relative min, and my y value, plugging in 0 into the original function, that's not too bad to do. If you plug in 0 cubed plus 12 times 0 squared, that's all 0, and then we add 5, so our y value is just 5.